Today we're going to discuss line segments and distance and what we're talking about, because there's some of you that were needing some extra help with line segments. Okay, line segments is a piece of a line, that's a part that has endpoints. So it starts and it stops. This is the way that you have the segments. This is the meaning, right? So this segment ends between A and B. So it looks something like this, a line that contains the points A and B. So here is my line that has the points A and B. Okay, now this line still goes on forever towards A, as well as going on forever in the direction of B. But there's a small piece inside the line that we can measure because it has an endpoint and a starting point. This is that piece in between. So notice I'm coloring this. Now, the line segment doesn't go over the line. I'm just doing this so that you see the measurement, that you see where the segment's coming from. So in other words, this is a piece of a line. So I'm going to bring that piece of a line here so you see it looks exactly like a line. Okay, again, here's point A and point B, right? This part is a piece of this line right here. Okay, but it has an endpoint and a starting point. Okay, this is something that can be measured, and it has a difference between a line because a line goes on forever in those directions. Okay, so this is a key thing that I want to make sure that I come across. If two figures have exactly the same shape and size, they're what we call congruent. Congruent is a very important word. Okay, congruence almost means the same thing as equal. Okay, when I say x is equal to 2, right? That's defining the measure. So congruency is very similar to that. It's not quite the same, but it's very similar to that. Okay, so when I say two things are congruent, they have the same shape and size. Like my left foot is congruent to my right foot, kind of like that, right? So that's what I want to make sure you talk about when you understand congruency. Okay, and then we have what we call congruency marks, and they're these little dashes. Right? Whenever you have a piece of a segment and they have the same amount of dashes, that means that those line segments are congruent. So right here, you'll notice that this line segment AB is congruent to this line segment CD. They have the congruency mark. Notice this one has one dash to it. This one has one dash to it. It's also been measured at 1.72 centimeters, as well as this one, 1.7 centimeters. Now, I can write this so that it's annotated, that you know. I can do something like this. Let's say I have line segment, I don't know, FG. Okay. And then I have this other line segment. Let's say this is XY, right? Well, I have no way of indicating that these two line segments are congruent. Okay, there's nothing out here that tells me that they're congruent unless I do some measuring, right? If I use a ruler and I measure it, then I can define that they're congruent. However, if by chance you see something like this where it has two marks and then I have two marks here, this is what we call a congruency indicator. This indicates that those two line segments are in fact congruent. So that way, if I were to say that XY was, I don't know, let's say 1 inch, right? This would indicate that FG is also 1 inch. That means they're congruent, okay? So in this case, I hope you see what we're talking about as far as congruency. The next thing we're going to talk about is the distance formula. Okay, this is when you have something on a coordinate plane. Okay, your distance formula. So the distance of PQ, right? So if you have a piece of a line segment on a graph, you can use what we call the distance formula. Now, in order to do this, you have to have the coordinates for the starting point and the coordinates for the ending point. And you have to label x1, y1, x2, y2. So back in the day when you guys were in algebra, you use these points to find the slope, right? Well, we're going to use those same points so that we can find the distance, meaning the measure of units between these 2 points. And we use this by putting in our values for x value, x2 minus x1 squared. So that means we got to use the exponent of 2 plus y2 minus y1 squared. Notice there's sets of parentheses. So before you square anything, you have to do whatever numbers are in parentheses and then square it. Plus, again, inside parentheses first and then square it. Then you want to add those two outcomes And once you add those two outcomes, you take the square root, and that will give you your length of PQ. Okay? This is something that we're going to go over a little bit more in detail, but I want to make sure that you understand this. Okay? All right, so the next piece says, find each measure. Assume that the figures are not drawn to scale. Okay, so I don't know that these two figures are exactly the same, right? So right now I have the measure of CE is 1.1 inches, and the measure of ED is 2.7 inches. So I have this piece of a line segment and this piece of a line segment, and it's asking me to find the line segment CD, right? So I'm looking for the whole distance of CD. Well, if I was looking for the whole distance of CD, I would just combine these two pieces, right, to make the whole distance. Now, what do we talk about combine when we're doing that in mathematics and algebra? You can pause here for a second. Okay, when we say combine, that means to add, right? So when I combine these, I'm going to add these two line segments. Okay, when I add these two line segments, I'm going to get 1.1 plus 2.7. That's going to give me 3.8 inches. So what that means is that CD is equal to 3.8 inches. Seems fairly easy, right? Now let's look at it a different way. Okay, here I'm looking for the line segment RS. Okay, and I'm looking for the distance from here to here, right? Okay. Now look at what it gives me. It's given to me that ST is 1.6 centimeters, but then look, it's saying 4 centimeters for the whole thing, right? So basically it's giving me the whole thing, and then it's giving me a piece. So what I'm gonna do is I'm gonna replace this piece that I don't know as an unknown variable. So I'm gonna place this as an X value, right? So kind of like what we did here on number 1, I added the two line segments to get my whole segment, right? So if I do that here, I'm going to get X plus 1.6 equals 4, right? This is literally the exact same setup I did on number 1 on this example here, right? I added the two segment pieces to get the whole segment, right? So X plus 1.6 equals 4. So in order to solve for my missing piece, I subtract 1.6 centimeters from both sides, right? Because I'm going to use my subtraction property of equality. Right? And I get X equals 2.4 centimeters, right? This makes sense. I hope so. Notice I'm adding the two line segments to get my whole segment, right? And we're going to talk about this here in a second. This is what we call the segment addition postulate. And we're going to talk more about that in the next video, okay? So, in algebra, right? Let's look at this piece. It says, find the value of X and BC if B is between CD, right? So what I'm going to do here is I'm going to draw this line segment, right? And this line segment has 3 points if you look at it, because it says B is between C and D. So here I have C, here I have D, and apparently somewhere in here, right? Somewhere in here, not in the middle. It doesn't say in the middle. It just says somewhere in between, right? So I'm somewhere in between these 2 points, and it doesn't necessarily mean the middle. So I'm somewhere in between these 2 points, right? And B doesn't necessarily need to be there. It can be anywhere between. I can be really close to C, and I'm still between C and D. I can be really close to D and be in between C and D. Okay, I'm just going to put this there for, purposes just so we could see. Okay, let's go ahead and call this B. Okay, and this is not drawn to scale, of course, because I don't know what the outcomes are going to be. All right, so let's say right here, it's giving us some information. It's telling me that CB is equal to 2x. Okay, so this part right here is equal to 2x. Then it's telling me BD, so from here to here, is equal to 4x. Okay. Then it's telling me, it's giving me more information that BD is also 12. Okay, so it's giving me a whole bunch of information. Now it's telling me find the value of X and BC. So I need to find the value of X and BC based on this information that it's giving me for 3, right? If this is the case, guess what? BD is 4X. Well, it tells me BD is also equal to 12. So I have an equation, 4X equals 12. Right? Because they're the same. They're congruent. They're equal. Okay, divide both sides by 4, x is equal to 3. So there I found out my value of x. In this first situation, x equals 3. Well, if x equals 3, all I need to do is plug in the value of x here so that I can get CB, because that's what I'm trying to look for. So I'm going to plug in my 3 value for x. 2 times 3 is 6. So this tells me that CB is equal to 6. Make sense? All right. If you need a pause or if you need help, let me know. All right. So let's look at this next one. I'm going to go ahead and do the same thing. Here's my line segment. So you see it as a picture. I'm going to go ahead and put the point kind of right here. Again, it's not drawn to scale because I don't know my outcome yet. Okay, again, find the value of x and BC if B is between C and D. Doesn't say halfway, it just says somewhere in between. So here's C, here's D, and here's the situation where I'm going to put B. Okay, so there's C and D. Okay, so now let's look at the information it's given me. Okay, first and foremost, it's telling me that CB is equal to 4x minus 9. So this piece is equal to 4x minus 9. That's this whole distance right here. Okay. Then it's telling me that BD, so that's this distance from here to here, from B to D, is 3x plus 5. But notice it's telling me the whole distance is equal to 17. Right? The whole entire segment is equal to 17. Well, I need to find x and I need to find BC, right? So I need to find those two pieces. Now, in this situation, what I want to do is, again, I have this piece of the line segment and then this piece of line segment. If I combine these two line segments, I get my whole line segment, right? Which we know is 17. So in mathematics, what does combine mean? It means to add. So here I have 4x minus 9 plus 3x plus 5 equals 17, right? That's what combine means. Then after that, it's just simple algebra, combine like terms. I get 7x minus 4 equals 17, right? 4x and 3x is 7x. Negative 9 plus 5 is negative 4. Solve for x, add 4 to both sides. I get 7x equals 21. Divide by 7, x equals 3. Look at that, another situation where x equals 3. Now that I know what x equals 3, now I can plug that value of x in for the situation CB, because CB is the same thing as BC, right? So I plug in that 3 back in. 4 times 3 minus 9. 4 times 3 is 12. 12 minus 9 is 3. So this tells me that BC is equal to 3. Awesome. Go ahead and pause there. Let me know if you need any help. I'm going to go on to the next page. All right. Here we're talking about the line, the number line. Hopefully this will help you understand what we've been talking about, right? So it says use the number line to find each measure. So here I have x and y. Now notice when I find the measure of x and y, I'm not counting these numbers. I'm counting the number of units because measure is distance. Okay, so here is 1, 2, 3, 4, 5, 6, 7, 8. XY is 8 units. Okay. See how that works? I just measured it based on the unit scale that it's given to me. Now it's asking for WZ. So from W to Z. Again, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this one's 9 units. Now I'm putting units because it's not giving me a measure. It's not telling me inches, centimeters, and so forth. It's just telling me, so that's why I'm going with units. Okay? Units is a distinct measure that kind of covers everything. Okay? Now notice that one's actually longer than the other. Well, that's fine. That's because distance is always positive. It's always what we call absolute value. All right? Okay. All right, so now we're going to talk about some things in here, this time capsule. Let's see if we can go over this. Okay, it says graduating class has buried time capsules on the campus for East Side High School for over 20 years. The points on the diagram show the position of the 3 capsules. Find the distance between each pair of time capsules. So what I'm going to do is I'm going to go ahead and just find the distance between A and B. Right? So I'm looking for the distance between A and B. Notice on here, the line, the distance between A and B, it's not a straight unit measure. I can't count 1, 2, 3, right? Notice it kind of angles, it measures right here, right? So in order to do this, what I want to do is I want to label my points. Point A, I'm going to label it x1, y1. And point B, I'm going to label this as x2, y2. Then I go back, I can use my distance formula, okay? Here's my distance formula, just in case you were wondering, right? I labeled it. So the distance of AB is equal to the square root x2 minus x1, so 2 minus 4 squared, plus y2, negative 3, minus 9 squared. Okay, 2 minus 4 is negative 2. Negative 2 squared is 4. Okay, negative 3 minus 9 is negative 12. Negative 12 squared, right? Negative 3 minus 9. Right? Okay, so that's going to give me negative 12. So here again, here was negative 2 squared. This one's negative 12 squared, which gives me 144. I add these two together, and I get that AB is equal to the square root of 148. Okay, and you can use that in decimal places if you want. We'll see how that works. And that would be your distance and what we call units. Now, a lot of us remember, hopefully, reducing that square root, right? I want to make sure that we can reduce that square root there from Algebra 1, and we'll talk about that more, but I'm not really worried about that. Anyways, hopefully that clears a couple of things up. Let me know if you have any questions.